In this section we look at fractional indices. We start first of all just going back to the whole number indices that we've done before. We know that p squared means p multiplied by p. We also know that p to the power 3 means p times p times p. So what does it mean by p to the power of a half? How do we actually explain that? We know that when you've got a common base you add the indices. So in this case p is the common base and a half plus a half is equal to 1. So that statement's a fact. We also know that the square root of a number multiplied by the same square root equals the original number. For example, try it with 9. The square root of 9 is 3. 3 multiplied by 3 gets you back to 9. Let's compare these two statements. If you have a look at what's in red and what's in blue, the final part of both equations is the letter P. So we compare the two bits on the left hand side, we can actually match them and say that the square root of P has to equal P to the half, so that both of those equations now match. Let's have a look at another example. Again, we've got a common base of p and we're multiplying, so we add the indices. A third plus a third plus a third equals 1. So the answer is p to the power 1. We also know that if you've got the cube root of a number and you multiply it by the same cube root 3 times, you get back to the original number. Try it with something, for example, like the cube root of 8. The cube root of 8 is 2. 2 multiplied by 2 multiplied by 2 is equal to 8. Like before, both of these equations end up with the result of p. So if we match what's on the left hand side, we can see that p to the third is equal to the cube root of p. What about when we've got a fraction like 2/3? Well, the way to think of that is to split it up and use the index laws about multiplying the indices through the bracket. So p to the power 2/3 would be the same as p squared all to the power 1/3. Alternatively, you could look at it as saying it's p to the power of 1/3 all squared. So that's the way we treat fractional indices, which aren't necessarily 1 over some particular number.